so after evaluating these parts, oh my goodness, things are ringing. I'd like to talk about what you found on them. How do you know that they are cast parts? Yes?
There are parting lines.
There are parting lines. Almost all of them have parting lines. There are a few that don't. The flange does not, because they put the parting line right at a flat edge, so you can't see it. But all the rest have them. Okay, what else? Yeah? The surface finish is not so good, depending on the part, or depending on the need. Does the surface finish need to be any better?
No.
Not really. On black iron pipe, doesn't matter. On the turnbuckles, it's interesting that the turnbuckles are so bad, but that is just because they're running a mold to death when they do that.
I also noticed that the turnbuckle is like, it's dimply, like it's been cast, but it's also been tumbled. It's like a shiny dimply. And it just like, it looks like it's been run through some sort of tumbler.
Yeah, I don't think it actually has. I think it's the method used to make it. Yeah. Yep.
Are those die cast?
Those are die cast, right. So they were cast into a metal mold, so the mold would have been smoother. However, it is a really beaten up metal mold, and I guess they're just pumping more and more and more parts out of it, and they're continuing to go, and so that's why it's still kind of dimply. It should not be dimply at all. What else do you notice about them? Like, is there anything else that gives you an idea that it's cast? Yeah.
The material.
That's called cast iron?
Yeah.
Yeah, okay, that's an excellent clue. That's very good, yeah. Okay, what were features that you found that were possible because it's cast that would not be easy to do another way? Yeah.
Like the raised like stamps on like the side of the material, like just like have that in the mold ready to go, and it's like fills the space, and that's easy and cast compared to like other.
Absolutely, yeah. That would be super difficult otherwise. Like if you were machining it, you would have to machine away all the rest of the material, just leaving those letters proud. And that would be a bummer. And the reason that you don't want those letters carved into it is because black iron pipe is used as a pressure vessel in natural gas service. And so if you carve letters into it, then that is an area where the wall is thinner, and so you have more of a chance of the material failing there. So having raised letters is really important, and it's easy to do with casting. It would be very hard to do with anything else.
Having these, particularly the turnbuckle, the nice like rounded edges and sort of like ergonomic, I guess you'd say, like nice to touch corners that are easy to grab and sort of soft in all the directions.
Okay, yeah, so it's not going to cut you. It's kind of rounded from the beginning. Nobody had to go in and chamfer all the edges to make it that way, okay?
For this, I was saying like kind of like what she's saying, like with the kind of complex curvature. I mean, you could kind of make this, but like pouring this into a mold and getting kind of like smooth combination of curves.
Yeah, so the shape is really, it would be really challenging to do on the other. The intersection of the different directions, or especially on the L's, to be able to have that smooth a bore going around the edge would actually, by machining, be a very long process, because you would have to go back and forth and surface the entire thing. So it would be probably, I don't know, 30 to 45 minutes of machining to make all of that be completely smooth enough, especially to be in pressure service like that. What other things did you notice? On the black iron pipe, there is something that is really, that would be hard to do by any other means. Sorry?
Have a hole through it with the core.
The hole, yeah, but let's be more specific about the hole that's going through it. Yeah.
So the complex curvature of the hole?
Oh, the complex curvature is good, yes, and?
Looks like the diameter is like smaller on the edge and wider in the middle.
That's right. It is smaller at the ends and bigger in the middle. And so the threads protrude into the volume. Again, if the threads went into the sidewalls, it would be thinner in that area and it might fail. So the threads come into the flow path instead, and that keeps the walls strong. But that would be really hard to do otherwise, because you would have to do something to get in there and then widen it out on the inside. That would be pretty crazy. Okay, how about on the lead anchor, the wall anchor? Why was it cast? Yeah.
It also required a core.
Okay.
And the core sort of just fits.
Yeah, so it required a core that was in there. That one is probably, well, no, that one is also die cast as well. There is a feature on it that you can tell that it was die cast. Anybody find that feature? Yes.
Well, we noticed a parting line, and then also there was like a witness mark looking thing.
Yeah, so what is that witness mark? There's a circular witness mark on the side. Yep, that's the ejector pin. So it's the ejector pin hitting it to push it out.
That is?
Yep. Yep.
I
Where
was
does
gonna
it
say, it's, I mean, lead.
It's lead, that's right. You wouldn't want to have to machine this, you wouldn't want to have to make this any other way. You want to melt, you want to have a machine melting it, casting these, you want to keep everybody away from it, you want a big vent hood above it, and nobody near the machine. And so casting is a really safe way to do it, because you can keep the people out of it. Yes?
Why did they make it out of lead? Like, what was the point of making it?
So when you put it into the wall, you need it to deform and mold to the wall, and lead is really soft, and so that's why it's.
Could you have used aluminum for the same purpose?
Not very well. So aluminum is like, I don't know the exact number, but it's probably 100 times stronger. And so if you are trying to push it into the wall, it would not deform. It would instead remove all bits.
Metal.
Metal, it's awesome. That's what you were gonna say.
Totally.
Yeah. All right. What about, let's see. Oh, on the turnbuckle. Why does it have the big hole in the middle?
So
It's got,
the screws can go.
well, it's got this big clearance where you can see the screws. But what's the purpose? Okay, could be lighter, doesn't really matter. It's on a big cable. You're holding it to the ground.
Twist it.
Sorry?
It gets it purchased to twist it because it's flat, and you put a wrench on it.
You could, except that it has cast into both ends. It has a hex to be able to put a wrench on it. So you don't have to do the middle, but you can do the middle. But it still doesn't have to have the big cutout in there. What are they doing with that?
It helps you see how much clearance you have.
Okay, it does help you see, so it's kind of a secondary thing.
Maybe if it's like under a bunch of force, and like it's skinnier.
Skinnier?
Oh, well, it's probably so you
Good.
don't use less material.
Yeah, it's just saving money. It's
Oh.
they're just cheap. That's what it comes down to. They're just cheap. They're saving material. However, if you were doing this by a different process, you would not remove that material, because that would be extra time and money to remove the material that was in there. But because we're casting, we didn't put the material there in the first place.
For the like casting processes with disposable cores, like where they can't reuse them,
Yeah.
would it be more worth it in this case to like give it a core and then throw away the core, or just use more material most of the time?
That is an interesting question. I think metal is always more expensive than sand. However, on this one, it would not have to have a removable core, because you can lay that thing on the parting line and have half the mold coming up into that cavity from below and half going down from above, and you don't have to have a core at all, because you're gonna have to drill and tap the holes on the ends anyway, so there isn't really even a reason to put a hole there to begin with. You just make it all be part of the machining process. Okay? We good? All right. Yes.
Well, I was wondering if you could do an example of like, what do you mean sketch mold components required to make this part?
All right. Sketch mold components required to make this part. You have to have a sprue. You have to have runners. You have to figure out how you're going to attach the runners to the part. How are you going to get them to where they need to be? And that depends on how you're casting the part. Are you casting it sitting flat on the parting line? Are you casting it upright? There are different ways that you can do that. You just have to remember that you have to be able to Like on the pipe, you have to be able to pull the pattern out of the mold. On die casting, you just have to be able to machine the hole in the mold. But you have to figure out how it's going to remove from there. You would want to have vents to get the air out of there. You have a riser, all those things.
Love those
All right,
things.
I will take these back now, those fine parts,
I like the whole setup.
collect them and pass them to the end of the table.
Sorry.
That would be fantastic.
I have attention deficit, alright?
No.
Cool.
You're annoying. I don't like you.
All right. It's time for cold work.
Yes!
And if we're going to talk about cold work, that means we need to Kahoot it. So.
Really?
Get your Kahoot on.
Okay, pages. 55427.
We do Halloween mode.
Can we do
put Halloween
Halloween
mode on? Bottom, so you're for the
Doing best.
It's the same, it's just Halloween themed.
No.
Whoa, that's a long game then.
It's the same length as the rest of them.
Really?
Are we sure?
Yeah, they made
Yeah.
them longer. since
Nice
they were
work.
kids.
First in. Good job.
Ran out. Oh, it could be a mummy.
Wait, I wanna be Halloween. Oh, yeah.
I like my guy.
Just tell me what the
What do you mean?
Hey, what the heck?
You got there?
I'll change it. I'll change it.
I like yours.
There's an owl.
You should be the owl.
The owl was pit by.
All right, come on, let's go.
I'm done.
Let's not spend all day here. Okay.
Okay.
It's important to have.
Teamwork in the back row. Excellent. All right, here we go. Are you ready? 5,
4.
3, 2, 1, go.
We don't get
Nice.
Turn your own horn.
Man, whoever made this is great. Yeah, this.
What about it?
Yeah.
I no, I requires extra money. I did the opposite.
All right.
I want everyone to know that I'm the diamond. I didn't read them all.
Okay, good work. Excellent start.
Except me.
We'll put you in
Alexa being fantastic. There we go.
That's also what I chose. I actually did everything this style.
All right, it is recovery. So recrystallization is not about diffusion, it's about completely reforming the crystal structure. So recovery is when we are just heating it up to that warm work region between 0.3 and 0.5 times the melting temperature, and then diffusing the interstitials out of the way so that the dislocations can continue to move.
Kira again.
Kira, if you win this one, I'm gonna be so mad.
I'm just,
I swear this. Oh gosh. I get the feeling. I was that
Okay. Slip is the process of the dislocations moving through the material, but specifically aligning things in the direction of of the deformation is called texture. And so it's specifically something that happens in rolling a lot. It aligns the grain patterns along the direction of rolling. And then you have to be really careful what you do in future processes, because if you do it along the line of the texture, the material will fracture. So you have to make future processes happen across the texture. Yes?
Can you release these on our canvas?
Afterwards,
Yeah.
to see the questions?
Yeah.
I will try. I don't exactly know how.
If you can.
Ooh. All right, a lead change. Here's a line.
No, I'm scared.
It's process primarily. All right, recrystallization is the right answer. So if you are losing all the strain hardening and you're resetting the ductility, that means you're recrystallizing, you're reforming the crystal structure, as opposed to recovery. In recovery, you're not getting all of the strain hardening lost, nor are you achieving all of the ductility again. Alexa holding the lead.
Alexa's
All
holding
right,
it.
Oh, God.
some changes coming around the corner.
Yes.
All right, look at that.
Finally.
Good work, everyone. Who was fastest? All right, still doing well. Okay.
The Shakira.
That's to say achieve. I would achieve. Achieve. I achieve. Okay, rapid oxidation is the correct answer.
I got it wrong.
Expensive tooling. There are two, actually all the tooling is expensive on either hot work or cold work. On cold work, it's expensive because it requires a huge amount of force to reform the tool. So it requires tooling that can handle very high forces. If you're doing hot work, the tooling has to be able to handle very high temperatures, so it's also expensive tooling. So anyway, you always lose that way, but whatever. Oh, new leader.
Motto.
Oh, God.
I'm sure you're wrong. I think it's.
Oh, I got it.
The double negative of no loss of ductility is not very nice. But anyway, strain hardening is not part of hot work generally. You can move it so fast that you can get a small amount of strain hardening, but it won't last very long unless you quench it. And so, grain growth, we get a ton of grain growth in hot work. And so we are always fighting the grain growth as we go through the process. You have to prevent the, hey, come on, listen.
Dang it, Kira, how are you faster than me, bro?
Oh my gosh, it's a close one.
Oh
Whoa,
god.
select. Wait, I've never done this.
No!
Don't do it.
Mother, what?
Fuck. What they
How
select?
many?
I just
I'm
said
going.
I just can we talk about metals or plastics instead?
Can we please discuss plastics?
No, I'm doing everything except for the rest of it.
Alright.
Oh my god.
They're all fine.
I only got 3 points. Wait, did you get more points for getting home?
Oh, you got more points than you got all of them.
Really?
Yeah. I just got
Oh.
sent to like
Max? Motto?
Motto?
Yes!
Made my week. This is the win I needed, guys.
Feel motivated?
Made the week.
I didn't realize we were supposed to select all 4. I didn't feel
I
as
know we
strongly
get
about
more
talking about
points for doing
plastics.
that.
I did want to discuss
I
plastics.
didn't know that either, guys. Okay.
Big for myself.
That was great. Good work.
Oh god.
Guilty for cracking jokes now.
All right, I wanted to talk briefly about the water jet assignment, which appeared today. And so I will try to make this bigger so that you can see it, but we'll talk through it. So the water jet assignment appeared today. It is due at a funny time. So that's something to pay attention to. There is a model, and the model looks like this, that you should download, SolidWorks model. It's in the assignment. And that SolidWorks part you should immediately rename to have your design rather than turning it in as Gill Spinner design, because then it's confusing because I have 24 Gill Spinner designs and I didn't design any of them. Rules for what you can do. You must not change the size or location of those 4 holes. So they have to stay where they are. 3 of them are going to be used for fixturing, and the other one is a clearance hole when we come in to bore out the center so that it fits the bearing well, except that we buy cheap bearings so they don't always fit. But anyway, that's different. Your part cannot be larger than 4.5 inch total diameter. In general, that's because if you make it larger than that, you can't spin it because your hand's not that big. You should make your spinner interesting. If you make it really simple, you will be disappointed in 3 weeks when you're cutting yours out and it's really simple and other people have spinners that are pretty cool. And you'll feel like, wow, I should have worked harder. And also it's a requirement because it's up here under the rules and limitations. You should avoid holes smaller than 1/4 inch. That's because the water jet has to start the cut and it has to lead into it. And if they're too small, it will cut into your part on the lead in, and so that will be a bad thing. Now you can have sections that are smaller than 1/4 inch. So like if I wanted to, I don't know, make a thing and that thing got smaller in this section. So I was cutting out, I don't know, an intestine or something. This section can be smaller than 1/4 inch wide. The kerf of each one of these is 0.030, so you probably should not get less than 100 thousandths wide, but you can be less than 1/4 in a location. You just have to have a bigger space to start with. And you are limited to 15 holes other than these 4, so a total of 19. And that's just because it takes a long time and a lot of garnet to start the hole. It's having to shoot sand at the surface of a piece of aluminum fast enough that it can erode its way through 3/8 of an inch of metal. So that's a lot of sand that it takes to do that, and it takes time too. So anyway, you're limited to 15 holes in the part. Now, if you have one big cut all the way around your part, that's one cut. So if you make big holes, they get you more space or more time. Once it is cut through the material, it goes quite fast. Remember that the center hole is going to be larger than it shows, and so there is a drawing a little bit further along, and also in the model there is a dashed line that shows what size the hole will be eventually, because we're just water jet cutting this hole and then we will bore it out later on. All right, things that your part will be graded on: that it follows the rules and limitations, that it is creative and interesting, and that you uploaded it correctly in a zipped folder with the files that are required so that I can work with it. Questions on any of the rules? Excellent. Nice. So, some things that are important. There is a sketch that is labeled, "Your design sketch goes here." That should be a clue. So you can select that sketch and edit it. That's where you should put your sketch in, and then you can extrude the cut through the material. That's the easiest way to do this, is to extrude a cut. Please don't go and make a totally different model. When people do that, they tend to not quite get the holes in the right location. If the holes aren't in the right location, it won't fit on the fixture and you can't make your part. So start with this sketch. Gonna create some sketch. Here's the Try Mickey Mouse. And then it will extrude. You extrude the cut. You may have to flip the side. It has the flip side to cut as one of the options in SolidWorks. And so, or reverse anyway, you can flip the other part and you can extrude that. If you're having problems getting yours to extrude the cut, please contact me. I can help you out on that. Remember that the hole in the middle is going to be bigger in the end. Yes?
Do the 3 holes have to be like working into this last part? Like you can't cut them out?
That's right. You can't cut them out because we have to use that to fixture the part to do the machining. So after we've water jet cut it, we're going to put it in the CNC machine and face it. You're going to do the path planning for chamfering the edges of the part. Then you're going to create a drawing. So using make drawing from part, you're going to use ANSI A landscape as the drawing size. So let's, right now, I need you to pay attention to these rather than trying to make a part, okay? Because these are really important, and if you don't do these, we can't make the part. And then I need you to turn off display sheet format. If you don't do that, then when you go to water jet cut your part, you have to remove all of the stuff around the outside of your drawing. And everybody else is standing around waiting for you to do that. So it's nicer to all your classmates if you have removed the sheet format. And then you will take your part and you just drag it onto the drawing view. And you want to drag the one that's sort of a top view of your part. After that, you should save it. Make sure that the scale is 1:1 so that it comes out the right size. You may have to check use custom scale to get 1:1. It depends on the way it was created. Sometimes that happens for reasons that are not totally clear to me. And then you can click the green check mark. It would be great to remove the whole centers. You can just select them and use the delete key. That would also save time, but it can be done on the water jet as well. Check under tools, options, units to make sure that you're in inch pound seconds. If you're in millimeters, then we have to scale it by 25.4, and that takes time, but it's okay. We can do it, but it would be better to follow the directions. And then finally, save it as a SolidWorks drawing, and then most importantly, save it as a DXF, because the water jet uses DXF files. Then you're going to take your solid part, your solid drawing, and the DXF files, zip them in a folder, and upload them. So why do they need to be zipped together? When you upload something to Canvas, it appends a whole lot of information. First of all, it says your name, and then if you turned it in late, it says late in capital letters, and then it has a long string of things that probably has something to do with the date and the time and I don't know what else. And then it has the file name that you actually submitted. Well, because these are associative, the solid drawing has to look back at your part to be able to get the geometry. And if the name of your part is no longer correct because Canvas appended all this stuff to the beginning, then we can't use that easily to make a quick change if we need to make a quick change. Questions about any of this? Yes?
What is your like favorite design that someone has done?
I don't know that I have a favorite. There have been a lot of really good ones. There are some that are just visually pretty cool to look at. There have been some that kind of look like an atom or a bunch of overlaid shapes. There have been some that have been wicked sharp, so when you spun them, you would rip your hand up. There have been a lot of animals. There are cats down there in the display case outside the manufacturing space. It doesn't really matter. I don't have a preference. I just want you to work on it some, make it fun.
Are we doing the toolpath and chamfering in this class?
Yeah. Yeah, we will do the toolpath planning in SolidWorks using HSMWorks. So that's, I don't know, 4 labs from now or something. We'll do that and then do the machining in the lab after that. Any other questions? All right, great. Let's see, I need to get rid of this. Yes, it is time to talk about class, finally. You know what, we're gonna take a 5-minute break, so 1 after.